This, of course, gets people who study astrobiology extremely excited that there could be some kind of abode of organic chemistry and life that's shooting out into space, and all you have to do is go sample it, with a spacecraft that flies by. Well, it turns out not to be quite so simple.
Fun to be. Yes.
They are going to fly by close to that, aren't they?
Right, yeah. So later on in the Cassini mission, in a couple of years, they are actually going to fly right through the plume. Twice, actually. One sort of, they're going to do one pass with Cassini sort of going like this, and then one where they just skim right through it like that. And they actually have a little detector that they can use to collect some of the dust. They can't do some like really complicated chemical analyses on it, but they can do some basic stuff. And that should be really interesting.
Is that similar to a comet?
Yeah, so that's the question. Is this like a really big comet?
Yeah, really.
But on a comet, you always find these jets coming out from where the sun is heating up the comet. Here it's on the South Pole. It's like the part that gets the least sunlight. So it's something internal instead is driving this.
So there must be a lot of pressure to push this material out.
That's the big question. What is it? So this is what I was getting to. What's the source of these plumes? Is there some kind of pressurized water down there that's shooting out of these cracks? Is it just that you have hot, really warm ice and it's just evaporating into space very quickly? Those are a couple of very different ideas that have different implications for what's going on in there. And we're trying to distinguish between those.
Is the geyser continuous, or does it come out?
As far as we know, it's continuous, but we've only been there for a couple of years. Right? So it's been going on, Cassini's been there, but that's not very long yet. We don't know if it's continuous over solar system history. And the problem is, this is not sustainable over solar system history. If you lose that much mass off of Enceladus for all of solar system history, the rest of Enceladus' ice is just going to disappear in a billion years. I mean, the moon will just sort of fizzle out and nothing will be left. So obviously...
But there's no part of Enceladus orbit where this will happen and another part it won't happen. It happens all the time.
Yeah, it seems to be happening all the time. Yeah, while we've been there. Yeah, it's not like it goes on and off as it goes around Saturn. It just seems to be continuously shooting out material as it goes around. It's strange. Although, there are some questions about that. We don't have enough data to actually know whether they sort of rise and fall. We know that there's always something shooting out, but we don't know whether it's always the same amount. So we've only gotten a few observations so far. We have like 3 or 4 data points. And we can't fit a curve to it yet. Does that make sense?
Yeah.
So the question is...
Are there any impacts just opposite the pole? I mean, the North Pole would be much.
No. There's a few little craters up there. It's a big mystery why there's nothing obvious. And Steve was asking me when he was asking me to give this talk. He asked me to talk a little bit about some Enceladus work that I had done a couple of years ago when this discovery was first made. And it turns out that Enceladus, there is something funny about the shape of Enceladus, that it's a little squished at the South Pole. And the Cassini team who worked on this said, it says it's mixed ice and rock interior, that's the best fit. But a colleague and I did some work recently where we found that if you just melt some of the ice below the South Pole here, since water is denser than ice, it'll contract, and you can get this big pit over the South Pole, and you can actually exactly match the shape of Enceladus by just melting this little sea that's below the ice, right below the South Pole. And it turns out that the amount of heat that you need to make the right size sea to explain the shape of Enceladus is the amount of heat that we observe coming out. So the story all fits together very nicely. That maybe there's some kind of volcanism going on down the seafloor here. It's heating up the ice, it's melting it, it's creating this little localized bubble of water trapped beneath the ice. And that sort of expands and melts. And eventually you have this sort of sea beneath the South Pole, and the South Pole kind of crunches in. And maybe this is something that's driving those geysers. It certainly matches the heat, those gigawatts of heat that we see coming out of the South Pole. The exciting thing about this is that here we have hot rocks in contact with water. this is the kind of environment where you find critters living in the Earth's oceans, at hydrothermal vents down on the mid-ocean ridge. And so again, astrobiologists will get excited about an idea like this. Unfortunately, we don't quite have a way to prove that this is really going on yet. And unfortunately, the story's gotten more complicated this year. How many of you saw this picture on the cover of National Geographic this year? I think this is one of the most beautiful space pictures of all time. So this is a picture of Saturn looking from the position of being eclipsed by Saturn. Okay, so Cassini was behind Saturn relative to the Sun. In fact, you see a little sun glint that's sort of peeking out behind Saturn's atmosphere here. So you see the rings backlit here. And this big ring that you see out here, this is the Enceladus ring. So this is all that ice dust that's been left out there. And Enceladus is actually this teeny little dot that's right there in the middle of that ring. One of the coolest things about this picture, I don't have a zoom up, but if you zoom in right about here in this picture, you can see the Earth right next to Saturn's ring. So it's kind of cool.
How much?
But looking at this E-ring from the Earth, astronomers have just figured out that there's a little problem with this ocean idea where you have a pressurized ocean that's shooting out these plumes. And that is that this ring is completely devoid of sodium. And sodium is something that glows very nicely. We have sodium lamps on streetlights. Astronomers know how to find sodium. It's one of the most obvious things that astronomers can detect using the spectrometer. And down to the 6 decimal place detection limit, they can't find any sodium at all in this E-ring. And the constraint that gives is that even if that ocean was even if it was fresh water that you could drink, like a lake or tap water, that kind of fresh water, that still would have a lot more sodium in it than what they detect out here. So
it's distilled water.
It's distilled water that's coming out, essentially. Yeah, exactly. And that's a problem for that water having ever been in contact with rock before, because if you mix rock and water, sodium immediately comes out into the water. I mean, that's why even fresh water has quite a bit of sodium in it, because it's run across the stream bed for a few days and it's picked up a lot of sodium.
Is there a type of rock that doesn't have sodium in it?
It's a really major constituent of all rocks. The thing is, now if you want to explain these plumes from coming from a pressurized ocean that's in contact with the rocks, you have to deal with this, and you have to start making up exotic kinds of rock, or you have to make up some kind of way of getting the sodium out first, and the explanations start to fall apart.
It is water.
Yeah, it is water. It is water. It just turns out it's really pure
It's
water.
distilled water.
It's weird. So I don't know how to deal with this yet. I personally think it's still possible that... I personally still think it's possible that there could be a sea down there, but maybe it's not the source of the plumes. Maybe the plumes are being... maybe it's just ice that's evaporating into space very quickly, and it's just being warmed up by this warm water down there. So that's the big question. Let's see. What am I doing on time here?
Doing fine.
Okay. So stay tuned to that. I want to wrap up now with the big guy, Titan, the big bully of the Saturn system, and Titan has this core on the inside, we think, that's made of rock and metal mixed together.